Okay, this is exercise 10H, using counting in probability. So we'll be either using permutations or combinations in these probability questions. Remember, the probability of an event, isn't it the number of favourable outcomes? Number of favourable outcomes over total number of outcomes. So when we do probability using counting, basically we'll either be working out a permutation or a combination up here, or a permutation or a combination down there. So you're doing like two questions within the one question, and then you're just putting what you want over the total number of arrangements or outcomes, okay? I should probably put total number of outcomes arrangements, because they are going to be arrangements. Okay, so number of favourable outcomes or arrangements over the total number of arrangements. All right, so I'll just let you write that down. So exercise 10H, using counting in probability. And also, before we start, does order matter or not? Now, if it is yes, order matters, or no, order does not matter. So if order does not matter, is that, do we use C, choose, or P for permutation? So that's choose. So that's a combination. So it'll be choose notation, like choose. So it might be, for example, something choose 3. So we'll use NCR for those. And if order does matter, you can either, it's called a permutation, you can either use the P notation, or you can use the factorial notation, or you'll use where you wind down and you might go 7 times 6 times 5 or something like that, okay? So, or you'll use part of a factorial. You'll just do the first 3 steps, all right? Now, so does order matter? That's really important. If it does, you'll use a permutation. You'll either use N, instead of N choose R, you'll use NPR, or if it's going all the way down, but it won't in these questions, we're probably, we might use N factorial for the denominator sometimes, okay? Or we might do something like, for example, something like 7P3 is the same as doing 7 times 6 times 5. That's the same as doing, say, 7P3, where order matters. You want, there's 7 people, not that you want to choose them, or they're running a race, and how many ways can they come first, second, or third, would be this. So order would matter for that. Now 7P3 is the same as doing 7 times 6 times 5. You'll use the N factorial more than likely on a denominator where order matters. Okay? So I might just put this N factorial. You could use that as well, usually for the denominator. Okay? Not sure yet. We'll just see what the questions have. Okay? So order not mattering is the choose. Order mattering is the P, or this type, 7P3, for example, 7 times 6 times 5. Order mattering is factorial notation as well. Okay? All right, so that's pretty much what you need to know, and then we'll need to apply it to our questions. They guide you with the denominator and with the numerator. So they say a committee of 3 is to be selected from 9 members in a club. Does order matter? No, it doesn't. I just want 3 out of 9. If order did matter, it would be 9 people are running a race. In how many ways can I get first, second, and third? All right. But this is just, I just want to choose 3 people from 9. It really doesn't matter the order in which I chose them. Okay. So girls, how many committees can be formed? So a committee of 3 is to be selected from 9 members in a club. How many different committees can be formed? Yep, 9 choose 3 is the number of committees, which is, if you do that on your calc, you get 84. But part B says, if there are 5 men in the club, what is the probability that the selected committee consists entirely of males? Now let's just see how many ways we can choose 5 males first, And then we're going to put that answer over the 9 choose 3, over the total number of ways we could choose 3 people. So the number of ways of choosing 3 males out of 5, isn't it? Do you get that? So girls, I'm not doing the probability yet, okay? If there are 5 men in the club, what is the probability that my committee will all be males? Let's just see the number of ways we can choose the 3 males out of the 5. What's that? 5, choose 3 is 10. So therefore the probability of 3 males will be 10 ways of choosing 3 males out of a total of 84 ways of choosing any 3 people. Okay? So see, that's our favourable event, 10, and 84 is the total ways of choosing 3 people. So part A is the total number of ways of just choosing any 3 people. Part B, there are 10 ways of choosing 3 males. It's 10 out of 84, which is 5 out of 42. Okay, so with these questions, you're just doing perms and coms, but you have to do it twice. One of them will be the total number of ways, and the other one will be what you want on the numerator. 2 says the integers from 1 to 10 inclusive, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, meaning both 1 and 10 as well, are written on 10 separate pieces of paper. The integers, there are 10 numbers there. 4 pieces of paper are drawn at random, okay? Find the probability that the 4 numbers drawn are 1, 2, 3, and 6. Now, before we even start, they're not asking us to form a number like 1,236 or 1,326 or 6,321. It does order matter for this. No, they just want those 4 numbers drawn. Doesn't matter what order. So are we using choose or are we using choose? Okay. Now, they do want those 4 numbers, 1, 2, 3, and 6. Don't worry about that. Remember, the first thing we need to do is work out our denominator. In how many ways can we just choose any 4 numbers? So number of ways to choose any 4 numbers. Yeah, any 4 numbers. That will be our denominator. Does that, okay? So it's 10 choose 4, which is 210, if you do that on your calculator. So part A, the probability of choosing a 1, 2, 3, and 6. It's easier than what you think. If you just want those 4 numbers and those 4 numbers only, that's one of, yeah, you can. It's just one way you can choose those. That will only happen once, that you get the 1, 2, 3, and 6. You want to do 4 choose 4? We could. Yeah, you'd still get 1. So the number, so the probability of getting 1, 2, 3, and 6 equals question mark. Well, 1, 2, 3, and 6 can only occur in one way. So therefore the probability is 1 out of 210. There are 210 different combinations of those 10 numbers there. 210 different combinations of 4 of those. Well, 1, 2, 3, and 6 will just be one of those 210 ways. How many ways can you get 1, 2, 3, and 6? Just one way. No, the order doesn't matter. The order doesn't matter. So if I started writing them all out, so there are 210 different combinations of those 4 numbers. I can go 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6, 1, 2, 3, 7, 1, 2, 3, 8. And I could list the whole 210 ways. Then I could do 1, 3, 4, 5, 1, 3, 4, 6, or whatever. I could systematically list them all. 1, 2, 3, 6 will only occur in one way. But order doesn't matter. I just want to choose the numbers. So girls, we know that there are 210 ways of drawing any 4 cards. The number 9 is one of the numbers drawn. So number of ways to choose number of combinations I'll put with a 9. Number of combinations with a 9 are. So number of combinations with a 9. We definitely want the 9. So that's got to be in there. That's 1. All right, girls, so don't worry about that 9. And then how many digits are left? 9, choose 3. Yeah. 1 times 9, choose 3. So there's my 9. I have to choose it. I've got 9 digits left, and I still want to choose 3 more. So it's 1 times 9, choose 3. So number of combinations with a 9 is 9, choose 3. Therefore, the probability that you get a 9 is one of the numbers is, so 9 choose 3 is 84. Yep, it's 84 out of 120. 210, sorry. 84 out of 210. Yeah. Please don't forget, it says probability. Okay. So number of combinations with a 9. There's my 9. It's got to be there one way. Order doesn't matter. Times 9. Probability and 9 is one of the, what's that hash symbol? Number, isn't it? Isn't that the number symbol? Is one of the numbers. Oh, you can just go NO here, NOS's, numbers. That it's one of the numbers. All right, let's see how we go with the next one. Remember, our denominator is 210. So the probability that 8 is not drawn. So if you don't want 8, you're just choosing from how many? I do. You know how B is the number probability that 9 is one of the numbers? Yeah. So therefore the probability that 8 is one of the numbers is what? Wouldn't it be the same? Does it matter that I chose 9? So the probability that 9 is one of the numbers is 84 out of 210, which is 2/5. My part B could have been, what's the probability that 8 is, yeah, wait, what's the probability that 8 is one of the numbers? Isn't it the same? Again, it's 84 out of 210, which is 2/5. So now the probability that 8 is not one of the numbers will be just 1 minus 2/5, which is 3/5. Does that make sense? So just because that probability that 9 is not one of the numbers, if I asked you probability that 8, is one of the numbers, it would be the same answer as part B. Probability that 8 is not, remember that's a complementary event. It's just 1 minus the total probability. Now, you do get the same, or we could have done it like this. Probability that 8 is not one of them, a number. You could have gone, right, 8 is out. So we're going 9 choose 4. Does that make sense? Over the 210. Now 9 choose 4 is over 210, which is 3/5. So that's probably, I think that's easier. So, or we could go like this. If 8 is out, go back to your list and cross 8 out, 9 choose 4. 9 choose 4 out of the 210. Yeah, you did it that way? Yeah. All right, good to do both ways. All right, the other thing we could have done is 210 minus the 84, got an answer, put it over 210 as well. All right, now, D. Okay, the number 7 is drawn. So you know what I'm going to do? I'm going to write all the 10 numbers out. But 1 is not, so 1's out. Do you get it? 1's out. 9 numbers to choose from. 7 has to be in, that's 1. So 7's got to be in. How many are left? 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? So number of ways, so a probability of 7 in, 1 out. You know what I mean. Street talk. Okay, probably that 7's in, 1 is out. Well, it's the 1 times, 7 is in, it's the 1 times 1, 2, 3, 4, 5, 6, 7, 8. 8, choose 3 more numbers. You got it? 7 is in, that's a 1. 1 is out, it's off the list. There's only 9 numbers left to choose from. Again, out of the 210 because 7, because it's got to be in there. The 7 has to be in there. Yeah, it's 1. One way of choosing it. We're not worried if it's in first position, second, third, or fourth position. Order doesn't matter. So if it's definitely in, it's a 1. And then 8 numbers left. Oh, because you never plus with these things. It's this and that and that. When it's and, you multiply. I don't have to put the 1 times, okay? I got rid of the 1 because it can't be chosen. The 7 is in. I'm showing that it's in by saying that's one way of choosing it. You don't have to put it. Sorry? If 7 and 8 are in, it's 1 for 7, 1 for 8. No, not 2. It's 1 times 1. Yes. Times 7, choose 2, for example. Yeah. Do you get it? Because there'd only be 2 more to choose. So, I don't know. What does this equal, girls? Is that 56 on 210? 4 on 15. So Christy was saying if 7 and 8 had to be in, 1 for the 7, 1 for the 8, it's not 1 plus 1. It's 1 times 1 times, or 8 choose 2, depending if we want that 1 in or not. Okay? 1 times 1 times 7 choose 2. 2, because you only need 2 more after that. You've already got 7 and, yeah. That contains 3 red, 7 yellow, 5 blue. If 3 balls are drawn from the bag simultaneously, now that is the same as drawing 1 and then the second and then the third, all right? Doesn't matter. 3, for example, 3 balls drawn out at the same time, same probability as one after the other. There's obviously no replacement. Balls aren't being replaced. So find, and does order really matter, whether you chose yellow 1, 2, or 3? So, okay, girls, so how many balls altogether? So 15 balls altogether. I'm going to let you, first, can you work out the denominator? What's the denominator? Number of ways of choosing any 3 balls. Girls, we want the denominator first. Number of ways to choose or of choosing any 3 balls. Yep. Oh, yes. So we said order doesn't matter. Now, yep, which is 455. Now you can start working out your probability. So how many ways can we choose 3 yellows? There's 7 yellows, so 7 choose 3 over the 15 choose 3, and whatever that is. So that's 35 over 455, which is 1 over 13. Now, all the balls are the same colour. So that's probability of 3 yellow or probability of 3 what? Reds. Probability of 3 blues. Now what you could do, you can do each probability separately and add them, or you can just find the number of ways of getting 3 yellow or 3 red or 3 blue. Because when you've got the same denominator of a fraction, you're going to add the numerators anyway. Does that make sense? So do you want to just do the number of ways of getting 3 yellow or 3 red or 3 blue? See, or is a plus and is always a times along, okay? So 3 yellow, we already worked that out. That was 7 choose 3 plus, how about 3 reds? How could you get those? Yeah, because it's 3 choose 3 plus, that's or. 3 blues is 5 choose 3. I mean, I can, and that's what, 35 and 1. What's 5 choose 3? Isn't that 10? So that's 36, 46. So therefore the probability. So I'm just going to put the probability back up here. It's 46 out of 455. Which is, I don't think that can be, unless 3 goes into it. No, it doesn't. So there's your answer up there. Probability is 46 out of 455. All right, all right. Next one, 2 red and 1 blue. How do you do that? That's like where you've got a committee of so many men and so many women. Do you remember how to do those? Number of ways of getting 2 red and 1 blue. How do you do that? Number of ways of getting 2 red and 1 blue. Great, yep. So number of ways of getting 2 red, there's 3 red to choose from. 3 choose 2 times, not a plus. We want 2 red and 1 blue. And there's 5 blue, so it's 5 choose 1. Are we good? That's 3 times 5, isn't it 15? And therefore the probability of 2 red, 1 blue. We all good? 15 out of 455, 3 out of something. And, oh, all the balls are different colours. Well, all of them. So girls, for D, all the balls are different colours is not 1 minus all balls the same, because you could also have, if you do 1 minus the answer for B, you could still have 2 balls the same colour. So basically, all balls are different colours means you want 1 red, 1 blue, 1 yellow. That's what you want. Yeah. So all balls are different colours means 1 red, 1 blue, 1 yellow in how many ways? 3 choose 1 times, 5 choose 1 times, 7 choose 1, 3 times 5 times 7, 15, 105. So therefore the probability of the 1 red, 1 blue, 1 yellow is 105 over 455, which is 3 on. Okay, we're going to do question 4. Let's start. We've got a total of 15 people and we're choosing 5. So our denominator will be 15 choose 5. That's the way of choosing any 5 people. Sorry, 15 choose 5 is to choose any 5 people. So, for all of them playing AFL, that's 8 choose 5 over your 15 choose 5. What does the 15 choose 5 equal? Over 3003. So it's 8 choose 5 over 3003. So it's 56 over 3003, which is 8 over 429. All soccer, that's 7 choose 3 over 3003. And whatever you get, 7 choose 5, sorry, not 7 choose 3. 7 choose 5 over 3003. It's 21 over 3003, which is 1 over 143. Most of you have done that. Sorry about it being a bit squashed up. 7 choose 5 over 3003. 3 soccer, 2 AFL. How do we do it? 8 choose 3 times 7 choose 2 over 3003. 3 soccer, oh sorry, wrong way. 7 choose 3 times 8 choose 2. I got it the wrong way round. Yeah, 8 choose 2 because it's 2 AFL, sorry, 3 soccer times 7 choose 3. And we get, 980 over 3003, which is 140 over 429. Now, at least 1 soccer means 1 minus, so that means we want either 1 soccer, 2, 3, 4, or 5. That's too many to work out. So it's 1 minus no soccer, which means all AFL. 1 minus no soccer, which means 1 minus all AFL. So these are the probabilities we're working with now, not the numbers. So it's 1 minus 8 over 429, because the probability of all AFL is 8 over 429. So the probability of at least one soccer is 1 minus the probability of no soccer, which is 1 minus the probability of all AFL, which is 1 minus 8 over 244. Now, just one sec. 429. Yep. That's the easiest way to do it. Okay? You don't want to go, I mean, if you want to do it the long way, you can go 7, choose 5, plus 7, choose 4, times 8, choose 1. Like choosing 5, choosing 4, choosing 3, choosing 2, choosing 1. You'll be there forever. Now, at most, one soccer. That means you can have one soccer or none, or no soccer. We don't want more than one soccer person. So it's the probability of all AFL, so 0 soccer. So it's the probability of 0 soccer, that's a 0. 0 soccer plus the probability of 1 soccer person. Does that make sense? At most 1. So 0 soccer is all AFL, isn't it? So it's the probability of all AFL plus the probability of 1 soccer person. And I'll just do Ian last. So all AFL is 8 over 429. And 1 soccer is just... Look, girls, if you want, you don't have to do the probabilities separately. You can just work out the ways of choosing all AFL and the ways of choosing, or you do 2 separate probabilities. I might go to the next page. Probability of 1 soccer. How do we do 1 soccer? 7, choose 1 times 8, choose 4 over 3003. Sorry, can you see that? All right, I'll start again. I'll write that one out again. All right. Probability of at most 1 soccer equals probability of 0 soccer plus probability of 1 soccer. Look, girls, you can work out the probability separately, or you can just work out how many choices you've got and put it over the one denominator. Now, because we've already got 0 soccer probability worked out, I just put that one in. You can put the, so that's 8 over 429. We already did that. 0 soccer means all AFL. So probability that they're all AFL, we've already worked it out. Now, probability of 1 soccer, how many ways can we choose 1 soccer person? 7, choose 1 times 8, choose 4 over the 3003, which is the number of ways we can choose everyone, which is 8 over 429 plus, I don't know what that equals. What is it? 70? That's 7 times something. What's 8 choose 4? It's not 10. 8 choose 4. Over 3003, which is, 2 out of 11. And the last one, F, probability that we have to get Ian. So he's 1, he's got to be chosen, and now choose the other 4. Ian's got to be in there, so Ian is 1. And then there's 14, 14 people left to choose from. Choose 4. So there's Ian, he's definitely chosen. We want another 4 people being chosen out of the 14. Oh, Ian, a particular soccer. Oh, that's 7 choose 1. Ooh, no, he's got to be in there. No. He doesn't matter that he's soccer or who he is. He's Ian. He's got to be chosen. Yeah. 1 times 14 choose 4. Because he's a particular person. It doesn't matter that he's a soccer person. There aren't 7 ways of choosing him. If I go 7, choose 1, then you're telling me there's 7 ways of choosing him. There's not. He's got to go in. Okay, so he has to be chosen. There's one way. So it's that over the 3003, which is 1001 over 3003, which is 1/3. So girls, I can't put 7 choose 1 because that equals 7. There aren't 7 ways to choose Ian. I know he is. I'm not randomly picking Ian out of the 7 players. All right? He has to be chosen. He is one person that has to be there. Only one way to choose him. And then 14 choose 4 ways of choosing the others. Okay, girls, that will do. So if you can for homework, please do question 5, 6, 7, 8, 9. Now, do you remember like 9, how we do? Let's just talk about 9. Girls, remember, deal with restrictions first. Why don't we just quickly do 9 now? It won't, I'll just even watch it and you can look at the video later. Here's 9. I just want you to do up to 9. So, 6 people, of whom Patrick and Jessica are 2 of them, arrange themselves in a row. I'd be drawing my row of 6. The girls, let's do part A. If we want, what are the total number of ways of arranging those 6 people? Total ways, no, they're all there, of arranging the 6 is what? No, there's only 6. It's 6 choices, then 5, then 4, 6 factorial. Now, part A. If we want Patrick and Jessica on the end, P and J on the end, so number of ways with P and J on the ends. Wait, just be careful, Bart. Wait, that's not quite right. P and J on the ends. Can't I have P or J, so 2 ways, and then the other person's got to go there? So it's 2 times 1 times, arrange the other 4, times 4 factorial, whatever that is, 4 times 3 times 2, 12, 24, times 2, 48. So girls, P or J on the ends. P or J could go there. Once one of them is there, the other P or J goes there. So therefore, probability of P and J on the ends is 48 over 6 factorial. Is 6 factorial 7? Whatever. Is that what you get? And Patrick and Jessica, not 1 minus. So for part B, if you don't want Patrick and Jessica to be next to each other, it'll be total ways minus they are next to each other. So you can do the probability that they're next to each other and do 1 minus. Look, we can finish it tomorrow. Have a go. All right? I'll start. Yeah. All right, I'll do it now. All right. If you want Patrick and Jessica next to each other, we've got, where could they be? 1, 2, 3, 4, 5. If we want Patrick and Jessica to be next to each other, they could go there. Wait, they could go there, 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 or there. Would it matter? Yes. So they could go there, 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 or there. So it's 5 times, but they can swap around, times 2 factorial, or times 2. And then, so that's arranging P and J. So arranging P and J. But now we've got to put the other 4 people down, times 4 factorial. They're the other 4. So that's arranging the other 4. So we've got 5 times 2 is 10, times 4 factorial is 24. So we get 240 ways. Now, I don't want those ones. I want them not next to each other. So the ways, so this is P and J next to each other is 240 ways. P and J not next to each other. No, not 1 minus, because I haven't done the probability yet. It'll be total ways, because what's the total ways? It was 6 factorial was 720, so it's 720 minus the 240 is the number of ways that P and J aren't next to each other. which is 480. Is that right? So therefore, the probability that P, J not next to each other is 480 over the 720. 2/3. All right, so if you can just finish 5, 6, 7, 8. And these that we haven't worked out, 6 factorial, 720, 48 on 6 factorials, 48 on 720, which is 1 on 15. Simplifying that probability there was 2/3.